Everyone seeing that okay?
Yep.
All right. I'll go ahead and get started. So, well, you all know me on the call, Rich Pasquazi, now a sales engineer at Thermosystems. I'm joined by Luke Turnbull. He's on our BSS side of the Thermosystems company, so it's Building System Solutions. Luke, do you want to introduce yourself a little bit more than that?
Yeah, sure. Thank you, Rick. So my name is Lucas Turnbull. I am with the Building System Solutions, and what we are is a division of Thermosystems that brings together kind of the aftermarket sales area. So we do more of a retrofit, owner-facing clientele. Myself, I have a BSME from Bradley University, and I've been with Thermosystems ever since I graduated, which was about 6 years ago.
Great.
And that's probably enough for me.
All right. So yeah, Luke's going to be helping out today. He's been with the company longer than me, so if there's any questions that I'm unable to answer, I'll ask him to jump in. Did Shane just ask to be admitted? Anyone catch
I'm
that?
here.
Oh, hey Shane, how you doing?
Good. How are you?
Good. Glad you can make it. So yeah, we're just doing introductions. So anyhow, yeah, Thermosystems was founded about 20 years ago. It's a group of industry vets and sales engineers from around northern Illinois. We cover Chicago Metro, Northwest Indiana, Central Illinois, and focus specifically on HVAC. So we've been in business for over 20 years at this point, and just recently formed a relationship with Daikin. So we're their factory authorized service provider. We can do startups on centrifugal screw chillers now, as well as any other Daikin product, or frankly any other product that we rep, of which there are 20 different product lines that we currently rep. Personally, I've got my BSME from University of Illinois Champaign-Urbana, and I'm doing outside sales. You guys know me from my Victaulic days where I was more on the water side of things. So now I've hopped the fence and I'm over on the air side. I think I'm hearing an echo. Do you mind if we mute until we've got questions, guys? Is that all right? All right, cool. So anyhow, today we're going to be focusing on air treatment products. You've probably heard some of this, if not all of this, at some point. These are technologies that are either good for applications in existing buildings or new facilities, but that have been shown to reduce the risk of the spread of airborne pathogens. And obviously in the COVID era we're in now, anything we can do to reduce the spread of airborne pathogens, we want to make sure we're taking advantage of that. So there's really three technologies we're going to cover today: humidification, ultraviolet germicidal irradiation, and bipolar ionization. And our three product lines that take care of that are Condair, so they're the world's largest humidification manufacturer, and we rep them. UV Resources, they sell obviously UVGI for irradiating airstreams and surfaces, mainly airstreams, to kill airborne pathogens. And then last is Plasma Air, and they do bipolar ionization. So before I jump into that, have you guys been approaching any of these three solutions already in your facilities, or been approached by people trying to talk about these so
Shane
far?
might be able to share that. He has more knowledge than I do. Shane, do you know anything? Shane?
Shane, you're muted.
Maybe his speaker is down.
There. Is it better?
Yeah, we can hear you now.
There
Okay.
you go.
No, what I'm saying, you might know better than anyone else out of our group, because I haven't heard anything from anyone. I know we were doing negative things, but I don't know anything about UV or any other.
No, we haven't. I have not seen any UV devices in here at all. I've seen those on the outside years ago. I mean, they were all in a lot of clinics and stuff like that, but nothing in here.
Wait, didn't we do that on a CCD 11th floor just under helipad when Steve Feldman was here? That
It's
was the,
not a UV. Those were for fumes.
yeah.
Um,
Wha-
that was like an
Um,
ionization.
ionization, sorry, yeah, ionization. Okay. Yeah, so Richard, to answer your question, no.
Okay. All right. Well, yeah, these three technologies I'd say are by far the most promoted by ASHRAE, and that's really what we're going to focus our presentation on today. So this paper came out originally in 2014, so it's a position document on airborne infectious diseases, but it was reaffirmed obviously at the beginning of COVID here, February 5th, 2020. And it has a lot of good recommendations, including increasing outside air, getting rid of demand control ventilation, increasing filtration to a minimum of MERV 13, which would pick up, down to 3 microns, and then also UVGI. So that's probably the oldest, most proven technology of the bunch that we're going to talk about today. And then bipolar ionization, we will talk about that. That increases indoor air quality as well. And then more recently, ASHRAE released this paper. It's a position document on infectious aerosols. And this is more geared towards COVID-19 as opposed to just being a reaffirmation of an existing paper. And this is talking about the question of, is SARS-CoV-2 airborne or is it surface? And basically we're saying, COVID-19 is, we're going to assume that it's airborne to stop the spread of airborne transmission throughout our facilities. So again, most of what we're covering today is going to be mentioned loosely in this document, if not explicitly. And if you're looking for more ASHRAE resources, I can send you all this link, but it'll take you to a web page that has, these are all hot links. I think it's kind of a funny way to display it, but resources within ASHRAE, just in general, building readiness, and then building guides. And here's your healthcare one here. So I'll send you guys the link for this and you can peruse through it. But this is a great kind of non-biased approach to building readiness during this time. So let's start off with humidification. I guess, do you guys humidify at all in any of your buildings?
Yes,
Okay, which buildings in particular?
every building.
Every building. Okay.
Every building has some sort of humidification somewhere. Maybe not
Okay.
fully, but the older ones,
Right. What is the relative humidity you typically try to stay at?
It depends on the space that they use.
Okay.
I don't think we've had trouble meeting that in the past, so certainly something we need to improve on.
Okay. Well, the reasons for it, more comfortable for the people who are in that space, but also from a healthcare perspective, this is pretty huge. If you look at the ASHRAE position documents, they talk about the airborne dissemination of these pathogens via emitted droplets. So droplets that are emitted when you speak, when you sneeze, when you cough, sing, yell, whatever. And the idea is that the larger the droplet is, the less time or dwell time it will have in the air. So you can see here, this is a 100 micron droplet. This would stay in the air about 6 seconds. And then as it gets smaller, you see a longer dwell time. So 6 seconds, 10 microns, 11 hours down to as small as a half micron, staying in the air for 41 hours. And just to give you an idea, not that I'm going to say that COVID-19 could be by itself in the air, but its size is about 1/8 or 0.125 of a micron. So you get the idea that if it's sitting in a droplet of a half micron of saliva or mucus in the air, it could stay in the air for at least 41 hours. So how does this relate to humidity? Well, the drier the air is, the lower your relative humidity, the quicker that this will desiccate and that dry out pretty much and become a smaller droplet. As it becomes a smaller droplet, it's going to float in the air longer and then be able to spread to other people that are possibly in the space. So what we want to do is minimize the spread to others by increasing our relative humidity between 40 and 60%. And the original research that was done on this, you'll see in the Schofield-Stirling diagram. And it was done on a whole host of different bacteria, viruses, fungi, et cetera. But they found that between 40 and 60% humidity, you're going to see less travel and less growth of and spread of all of these different bacteria, viruses, fungi, et cetera. Specific to viruses, between 40 and 60%, not only does it spread less, but you're less susceptible because your mucous membranes are, I don't know, moist.
Yeah.
Your throat, the little hairs in there that move the mucus around are performing better. Everything about you is performing the way, you know, it was more or less designed, whereas at very low humidity, you're going to see less natural defense to those things. So, you know, a more specific study was actually performed on this. I'm curious, were any of you guys working in the facilities back in 2013 at UCM?
Yes.
Okay. Do you guys remember the study that was performed there that kind of covered this topic?
You know, I do a little bit.
Okay.
What, you know, looking at your chart, what kind of, so that even if we get above, like, you know, 80%, we have adverse effects of it. I'm surprised. You know, I would have thought the more humidity, it would grab the viruses and just fall, you know.
I agree with you. I was surprised to see this too. So really, the way Lucas and I learned more about the subject matter was through Dr. Stephanie Taylor. She was actually involved in that study back in 2013 that was done at UCM. And the question was asked, why does it spike up like that at the end? And this was during, you know, a special call that we put on. She didn't have an answer for it. I agree. I think the idea is that if you're properly treating your air and dehumidifying, you shouldn't get above 80%.
Yeah,
you should.
We'll never get there. So that,
right.
I mean, you know, with makeup air alone, there's no possible way we could get that high. But I was just curious that it actually goes back up.
Right. Same with me. I feel the same way. Luke, if you have a reason for that, feel free to share. But I've never had it explained to me.
I believe it has something to do. So it's all kind of a mystery. I don't think they have an answer for all of the things behind this chart. This chart is kind of empirical data. It's not, they didn't really dive into why. This is just what they found. So I think it has to do with the cells on like reproduction rate and, you know, different things like that. I'm not 100% sure though. I don't know that anybody is.
Yeah. So going to the study that was performed at UCM, just as a refresher, you know, healthcare-associated infections are a big problem in the healthcare industry in general. And when the CCD came out or was released, Luke, this is the Center for Care and Discovery. When it was opened, they were given an interesting opportunity because it was an unoccupied healthcare facility that was new that then became occupied. So the study was going to assess healthcare-associated infections. Those are infections that were obtained at the facility. Basically, people came in with a different problem, and then a new problem was created because they were in that space. The idea was to better understand transmission. The study was started 2 months before Center for Care and Discovery was opened, and then it was followed for a year. And they were monitoring indoor air conditions. They were mapping the microbiome, bacteria, and viruses in that space, and then tracking, obviously, infections. It used 10 patient rooms, 2 nurse stations, and you guys know the building better than me, so I don't have to tell you about it. But the different data points that they collected were carbon dioxide, light, temperature, staff and visitor hand cleaning, room changes, traffic, relative humidity, outdoor air, room pressurization. In total, we're told that they have over 8 million data points. And this is, all this information, again, is coming from Dr. Stephanie Taylor. And during a year period, about 15% of the patients in that space got HAIs. So they got sick beyond what their original condition was, something they contracted in the facility. And the biggest takeaway was that relative humidity was found to be the most significant factor associated with patient HAIs. And you can see here, these are the different healthcare-associated infections that happened throughout that year. As the relative humidity creeps up, you see those infections go down. So that led them to conclude that if you can keep your relative humidity at least at 40%, you'll see a much lower rate of infection. And again, it comes back to that idea of desiccation. If the air is more humid, those droplets won't desiccate and they'll drop to the ground, and they won't enter the airstream and spread to other patients in other areas. And obviously, using negative pressure is another way to address that problem. So that's why we dehumidify. And a normal room is going to have 4 to 6 air changes per hour. So after 10 to 15 minutes, you're going to see all the air in the room changed out anyhow. If it is being pulled out of the room and it's being sent back into your return, you want to make sure that what is getting into the air isn't going to be those infectious pathogens. So that's the idea here. And there's also some research that suggests that viruses are inactivated on surfaces around, or that inactivation is accelerated around about 50% relative humidity. So any questions on the concept at all?
Oh,
This is all part of ASHRAE that you're showing around here.
Yeah, all of this is covered in those papers, which I'll be happy to shoot over to you afterwards.
Yeah, I think Shane, it may be a good idea that we can get Rachel involved. I don't know how much Rachel knows.
oh, she does, because I've sat with, we've already, Rachel was the one that was a big part of this back in at that time. So she even understands, like, they have models that represent, how they flow throughout with the ventilation system and whatnot. And this specific with humidity related to infections, I sat in an ASHE conference just on this. So I'm a lot of this is coming back. I remember all this. So
yeah, good reminder before the second wave. So yeah, I mean, like I said, Condair is the largest manufacturer of humidification products in the world, formerly Nortec. They do steam generation, electric, gas, live steam. We can do atomization in room or in air handling units. We've got products for all of that. So if you guys need new humidification products for existing or new construction, we're happy to help you size all of that and include it in your equipment. I'm not going to talk too much on the products. You guys know what humidification is. So any questions on humidification before I move on to UVGI?
I just have a quick one, just on like the steam generation. Dave, I know you're familiar with some of these steam generating humidification devices. Are any of those ones that we would rather see?
We use a whole bunch of the direct injection ones.
Yeah.
Certainly don't want to see anything that's steam to steam. That's just asking for trouble. So we've switched to direct injection wherever possible.
Yeah, that's kind of what I thought. There's a lot of options here.
Yeah, absolutely. Okay. All right, well, we'll keep moving on then to UVGI. So this is by far the most researched and proven technology that we have against killing airborne pathogens, surface pathogens, what have you, talked about in the news all the time. But just for a recap on how UVGI works. It uses the UVC spectrum here of the total light spectrum. So that's anywhere from, UVC is classified anywhere from 200, sorry, I'm pointing at the wrong page here, 200 to 400 nanometers in wavelength. And there's 3 types of UV. So there's UVA, which we see here, and that is not blocked by the atmosphere at all. That's why you get a tan when you go outside. And that's between about 315 and 400 nanometers. Then you've got UVB, slightly more harmful. It's going to give you sunburn, and that's between 280 and 315, but 95% of that is blocked by the atmosphere. And then UVC is normally 100% blocked by the atmosphere, and that can cause extreme DNA damage. So it's a good thing that it is blocked by the atmosphere. But we can use it to also kill airborne pathogens. So basically the processes that will damage that DNA to keep them from being able to replicate. And we do that using low pressure mercury vapor light bulbs. So the peak for UVC is somewhere around 254, the peak kill wavelength. These bulbs are going to be in the 246 range. So you'd see a 2% drop in efficiency there, but you'll still see significant kills. So we'll go ahead and move on here. My notes disappeared on me. Hang on, guys. I'm going to restart my presentation. Okay, we're back. So that basically we use a bulb to emit UVC light that is going to kill any viruses, bacteria, what have you, mold spores that are in the airstream. And again, this is a heavily researched topic. So it initially came out, or the first research paper was back in 1877 that covers this concept. More recently was used, or I guess the first mass use of it was in the 1950s during the TB outbreak that occurred. And I'll show you some pictures on that in a little bit. But if you are interested in reading up a little bit more, this is in chapter 62 of the ASHRAE handbook. So if you actually have the book version of it. But if you want to read up on it, it's only about 12 to 15 pages. So if you want more of a history on it. So if we look at how we can actually go about killing viruses, bacteria, this is a good resource. It's a book that was written, Ultraviolet Germicidal Irradiation Handbook. And this is just a section that covers viruses, but you'll see here on the left side, all these different types of viruses that were studied. And really the factor that matters the most is this UVGI-K. And that's basically the intensity of UV that you need to get a 90% kill rate. And you'll notice coronavirus, not COVID-19, but coronavirus, has been studied since 1986 in water form, and then 2007 in air form. And this is the one that we really focus on when we go about sizing our UV treatment in air handling units or wall-mounted, upper room wall-mounted, what have you. And this is really where the software that we use gets its necessary kill rates from. So there's really 2 different ways that UVGI can be used. You've got upper room disinfection. So you see that here. And basically that's a lamp that's on the wall that has baffles that project a UV field out from the lamp and uses the convection, the natural convection of your body heat and your breath that raises whatever you exhale up into the top of the room, and then it's killed once it gets up into the top of the room. And you'd place this about 7 to 8 feet above floor level. So unless you got an NBA player coming in there, that would be high enough to avoid affecting anyone negatively. And you can see, but I'll address air handler or duct mounted in a little bit, but you can see that this technology was used back in the 1950s. So this is a classroom in the 1950s that used this very technology during those TB outbreaks. So typically you want to use this in rooms that have occupants who are immobile for large time periods where you're going to get that natural convection, and oftentimes where you have terminal HVAC, where you don't have a centralized HVAC system. So the way that you guys do, for example. If you want to see what this looks like in our office, this is our parts office, and you can see we've mounted one up on the ceiling here. So this is going to cover probably about half the room that we have where our employees are. And you can see, if you look closer here, those baffles, which keep that UV light from being able to come downward and affect our employees. So from a side view here, depending on the lamps that you purchase, ours have a range of 17 feet, but you can see the field that, the UV field that is projected from the lamp here. So outside of the field at the stray UV zone, you'd see 0.2 microwatts per square centimeter, and then within the field, you're going to see up to 200. Any pathogens that come into this space would then be killed by the UV light. If you look at the distribution within the room, it's kind of an oval shape. See that here? So you'd want to place them in the room such that they'd be able to take advantage of that field, and any pathogens that make their way into the airstream would eventually get into that field and then be killed. So then I could see this being used in an ER waiting room, or waiting rooms for even non-essential services. When I was going to the urology department there, they had a waiting room. I'd guess it was around 350 square feet, 2 halves. So if you threw one of these in each of those, not only is it a nice way to protect people, but it's also visible. So you do kind of get that warm and fuzzy feeling when you see it up there on the wall. Oh, look, they're taking care of this problem. They're addressing this problem, and I can see it with my eyes. Obviously, you do want to address the problem as well as best as you can. So the product itself is made up of 3 components. You've got your base and ballast here, your reflector and UVC lamp, so that's just going to reflect the light and send it out, and then your baffles, which angle the UVC light out so that it is not going downward towards the folks that are in the room. And we've got 3 different models here, the Glow 310 through 150, and as you might guess, the model number is associated with the square footage of the room that it can cover. So a 310 covers 310 square feet, and so on. And it does have, as I mentioned earlier, the furthest throw of any of these lamps, so 17 feet from the lamp, would be covered and be considered the kill zone for any airborne pathogens that make their way up. So any questions on the upper room?
So what is the power requirement for this?
This can be plugged in. This can be plugged into a wall outlet.
Okay.
Yeah.
And just what is the average cost?
I mean, depending on the sizes here, obviously, I think we generally say ballpark $1,000 to $1,500 per unit.
Okay.
Luke, is that accurate, Luke?
Yeah, that's pretty accurate.
Okay.
And
So,
the electrical circuit needs to be, it's like a light. So the amperage is less than 10, even on the big one.
and how long the bulb life? Once a year, twice a year?
With any UV unit, it's best to leave it on all the time, and you change the bulbs once a year.
Once a year. And how much that bulb runs?
Luke, do you have that one?
I don't have the exact price. It would be different for each model, but typically they're in the $100 to $150 range per bulb.
Okay.
Cool. Any other questions on upper air?
I'm good.
All right.
I'm good.
So as you can imagine, the upper air, like I said, it's nice for a warm, fuzzy feeling. It works extremely well in a room where people are sitting still all the time. But really, we suggest using the Airstream disinfection, specifically air handler mounted You can do duct mounting, but the challenge with this is you have a higher velocity in your ducts, and this is all about the time that the pathogen has to come in contact with the UVC light. So if it's flying by really fast, you're going to need a lot more bulbs, and ducts are just generally harder to access. Air handlers generally have the space. They also have lower velocities than a duct, and there's some added benefits to putting UV lights in your air handlers. Do you guys have any UV lights in your air handlers?
No, not at this time.
Okay.
I always thought it was a good idea. Nobody just has bought in yet, and this may be something that changes, especially with what's been going on lately.
Right, and the big selling point for these before COVID was around was putting them over your drain pans on the downstream side of the coil, because that's typically where you see a buildup of bacteria, mold, all sorts of gunk that you don't want, and that you have to clean out every 5 to 10 years, which always probably gets, put off till next year. So having those there can kill both the mold and the bacteria that would dwell in those drain pans and on the coil itself, and gives you all sorts of benefits. And I'll cover that in a second. But if we're talking about kill on the fly, the difference between putting them in for just cleaning of the coils is really the intensity. So you'd want 5 to 10 watts per square foot if we're just using it for cleaning the coils in the drain pan. But if you're using it for kill on the fly, you want 20 watts per square foot. And you can still put it downstream. It'll still clean the coils. It'll just also have the added benefit of protecting the people that are in the building by disinfecting the airstream. And that's a big contrast that I'll draw later to bipolar ionization. But just remember, this is disinfection. It immediately kills what's in the airstream. So what does a retrofit look like? You'll get the power supply with the ballast, the lamp holsters. There's an hour meter for the UVGI lamps to tell you how long they've been on. Obviously, the lamps, the wiring, the on-off indicator per lamp to make sure that they're all working properly, the mounting frame, and then you'll have a switch for the door because, again, UVC, you do not want to come into contact with UVC light. It's damaging for your skin, for your eyes, and you won't immediately feel it if you come into contact with it, but later it'll feel like a sunburn, or your eyes, if you've ever welded without a mask on, you'll get that kind of sandy feeling, and it goes away after a few days, but it's not comfortable and not good for long-term exposure. So that's why it's nice to have it in an air handling unit where it can be automatically turned off. So when we're talking about sizing these UV retrofits, what we use is this table here. And again, it's based on 500 feet per minute. And what we want to do is make sure that we're getting the right watts per square foot. So you can see here, based on that data I showed you earlier, for coronavirus, again, not COVID-19, but it's a suitable surrogate, the wattage per square foot that we need to get that 100% kill rate. So, sorry, I keep pointing at the wrong screen, to get that 100% kill rate. So here's our wattage per square foot. There's corona wattage per square foot, or sorry, 100% kill rate. You'll also notice that TB is on here, influenza A. So if you wanted to kill all of your influenza A in the airstream as well, you just up the wattage until you get to the percentage that you desire. But you've probably heard it said that coronavirus is kind of a wimpy virus in the sense that it's easy to destroy. You can see that here. You need a lot less wattage per square foot to kill it than TB or influenza. But this is the idea here, that we want to make sure that we have sufficient watts per square foot to get that kill rate. Any questions on that?
Yeah, I see this is for duct length 24 inches. So I take it from the picture as well. This is only 24 feet long. So we got, our coils are longer than 24 inches. So what I see, you have to install multiple length.
It really just comes down to the full cross-sectional area that you're addressing, and then the total wattage of the bulb.
Right.
Here
I see you need 8 total lengths for 24-inch duct.
Luke, go ahead. Sorry.
Yeah, that duct length is it's the distance of the lights from the coil. That's just a parameter in our manufacturer selection program. So that's not technically the length of the duct. You can change the exposure length of the air to the light. So typically our lights give off enough UV to really kill out to about 4 feet away from the bulb in any direction. The problem being is how fast that air is moving. That pathogen only sits in that kill zone for a certain amount of time. So that's what that duct length is really doing. It's in the math. It's giving an exposure time. So we can change that to whatever we have. Typically, I do a foot away from the coil, but you could do 2 feet. It depends on what you have on site, but that's really an exposure length, not like a true duct length.
Okay, but the retrofits I saw the picture, it appears to barely 6 inches from the coil. So how effective that would be if you require, I call it a foot away from the coil, either upstream or downstream?
So we like more exposure. We can really what we're doing there is we're backing into the mathematical models that were made in about the 1990s, 2000s. And we can size almost any UVGI system to give you a certain dosage. That dosage will correspond to a certain kill rate with a certain exposure time. So we set the exposure time constant, and then we size it to whatever dosage rate you want. Typically, when we're just quoting, we're doing a 100% kill rate. So that will give us a UV wattage that we need.
I got that, but then you're gonna need 8 circuits because you need 1 circuit per lamp. So here I see you got 8 units.
Okay, sorry. I didn't understand that. They can be put in series. So while you could do this all with 1 circuit, it just has to be sized high enough to carry the amperage, right?
Yep.
Yeah, they can be series. So not a big deal, or parallel, it doesn't matter. It just needs a single point of power.
So what is the length? What is the normal standard length you get?
Of bulb?
A lamp, whatever you want to call it.
Of the bulb, Harshid?
Yeah, bulb.
It's going to depend on the width of your air handling unit. So
Well, we got a big ass air handling unit. Some of them are 20 feet
I've seen
wide.
them.
Right.
Yeah, I mean, we measure them proportionate to, or basically size it proportionate to the size of the unit.
So, but it's not a custom lamp, correct? Or custom bulb? You have a standards that may come in a 4 foot long or 2 foot long or anything like that. That's what I'm trying to find out. Because I want to see, even if you do the retrofit, I don't want to make a big deal about it, putting 100 bulbs in one, upstream and downstream of the coil. And then someone, when they need to service that, it's going to be a nightmare for the coil to service.
Right.
So the 2 options in bulb length are 61 inches or 33 inches. Typically, if we're using a large air handler, we'll do 61 inches.
Okay, that's the limit then. Okay, that's what I was looking at it. Okay.
Yeah, and for service and long life, one thing that Rick mentioned that I really like to drive the nail home is even if you get an air handler, say this is your air handler in this picture, and you have the 7 or 8 lamps, right? That's sized to kill a certain virus, a certain percentage. Say, 10 years down the road, you don't actually need all those lights. We're past this pandemic. We're past the necessary need for that. You can remove some of those bulbs and still run the system, still have it wired up and turn it on with 1 or 2 bulbs in there, and you'll still get the coil cleaning benefits. So your HVAC efficiency will improve, your coil cleaning maintenance will decrease, you'll be using less chemicals, all of that fun stuff on this slide. But yeah, just one thought when you're thinking about service and long term.
Right. And that's a good, go ahead, Harshad, sorry.
And what is the life of the bulb?
About a year. So
Okay.
when you change out your filters, you change out your bulbs.
So if you got 8 bulbs and 100 apiece, they're $800 once a year.
Right. Yeah.
And if you got on a upstream and downstream, you are looking at 16 bulbs
Well,
Not necessarily.
or more.
well, you'd have less if you were doing it both upstream and downstream. It wouldn't be ×2. Downstream, you'd just be doing the 5 to 10 watts per square foot to clean, and then you do your kill on the fly upstream of the coil because your bulbs will be more efficient in the warmer upstream air before the coil.
Okay, and I saw on one of the earlier slide you were showing, I think it was ASHRAE recommended on the heating coil upstream and downstream right there. Nothing on the cooling coil.
So that's a picture out of the applications handbook. I honestly don't know why it is like that. It should be cooling coil.
Yeah.
Well, that's what that's what question comes up right now. And, this question may raised by other people, and that's why I'm asking all this now. So when we present this to some other people, they need to understand if it's not correct, then we don't want to see that.
Right.
We made it correct before we do any presentation.
So that is legitimately out of the ASHRAE applications handbook.
Correct.
So I don't know what they're saying there. We'll definitely have to double check what it was saying on that picture.
Okay.
But honestly, that wouldn't be a bad. You can put these anywhere you want. The reason why we're hounding the cooling coil is because we love the benefits. We love that a 15-year-old unit looks like it has a brand new coil. It doesn't need to go there. It actually is detrimental to the performance of the bulbs. But typically, it's the only place in an air handler that only sees metallic surfaces, because if you put this in front of the heating coil in this picture and it's shining on your filters, if you have a MERV 13 or MERV 16 filter rack right there, we have to change every one of those filters out to a metallic filter, which is very rare and very expensive. So most of the time, especially in retrofit, we don't get into going up above the coils. We don't want to replace all those filters.
Yeah, this is what Luke was referring to, Arshad. Right there in the manual. So
No, I'm looking at it.
And the manual, so the ASHRAE manual is great, and they also have a chapter that has to do with different type of fabrics and materials and their effect from UV. So those are both definitely very good readings if you want to double check us.
And you promise the coils will be clean like you show in this slide?
So if you look at this slide on the left-hand side is a coil I've seen a million times, and all that black stuff is it's mold. Right. So what you will do is you will actually kill the mold organism itself. If you leave the lights on 24/7 and they're sized for coronavirus kill rate of 100%, it'll probably happen within a couple days. You'll kill all of the mold and even in between the fins. Now you have to clean the bodies off of the coils, so it will require a wash down. But this is a real world coil. This is a before and after by our manufacturer real world coil. And those, if you look at the first bullet point on this slide, the engineering systems, October 2013, Rich, you should send them this. It's a real article. It's third party. It is using our manufacturer's lights, but to be honest, all lights are made by GE, Philips, and Siska or something like that. So our manufacturer is really just putting together the kit that you build and put in the coil. So all bulbs kind of work the same. So it's almost a independent UV study rather than a study of our manufacturer.
So once the mold is killed and everything, we just wash down the coil and everything will be brand new, I take it.
Yeah.
Good idea.
Okay.
And
Yeah, you're gonna have the skeletons that are left behind that need to get cleaned up, but yeah.
Right.
and I would, Rich, definitely send them that because it's
Yeah.
great information.
Yeah, we'll do.
Shane, Dave, chime in.
Yeah, I like it. I think you probably would. You definitely reduce the growth on the coil itself.
Right.
So, I mean, whereas, like you said, we'd still have to clean them. We'd still
Right.
have, dead organisms on there, but they wouldn't be growing on the coil.
Yeah. Yep. I got it.
All right, and not only would it, once it's clean the first time, it'll stay clean, and you're also not blowing mold spores downstream, which can also be detrimental. So, it's a combination of things. If you're seeing 10 to 25% energy savings because your heat transfer is better, you've got a lower pressure drop because the coils are clean. Even without COVID involved, this is still a good solution to have.
Right. One thing I like to say is our manufacturers were around before COVID. They weren't there to kill on the fly pathogens. They were there to do this. And there's entire companies formed around doing this. So it definitely works.
Okay.
All right, so any other questions on UVGI? We're going to switch to bipolar ionization briefly.
Yeah, we got
and
10
we'll wrap
minutes,
up.
guys.
Okay. All right, so bipolar ionization. The concept of this is adding energy to an atom to create an ion. And what that addition of energy, at least with our technology, you have two carbon fiber needles oppositely charged, and it's going to create negative ions. So that would be an atom that has an extra electron, because electrons are negatively charged, or a positive ion where it's dropped off one of those electrons. And the concept of this originally, as evaluated by ASHRAE, the concept is if you have oppositely charged ions, it's going to cause different particles to clump together and then adds to the efficiency of your filters. So that's the original concept, why both bipolar ionization was originally introduced. However, more research has been done that determines or shows that those same ions can create hydroxy radicals, which bond to the outside surfaces or create OH bonds on the outside surfaces of bacteria, fungus, viruses that later cause those viruses to self-destruct or be unable to reproduce. These also work very well in neutralizing odorous gases and aerosols, as you can see there, and VOCs. So going back to the virus side of this, there's been a lot of third-party tests performed. This isn't just our manufacturer. Other bipolar ionization manufacturers have similar data that shows that the use of bipolar ionization leads to a reduction in the population of those hazardous pathogens, airborne pathogens. The difference between this and UVGI is UVGI is kill on the fly immediately, whereas this is going to take, as you can see here, anywhere from 10 minutes to 1 hour to neutralize these different viruses. So this is more of a prevention mechanism, whereas UVGI is more of a disinfection mechanism. So using them in tandem could certainly be useful because not only would you be killing what's in the airstream, but you're reducing the overall population. And this was done by third-party researchers as well as our manufacturer, Plasma Air. So regardless of the bipolar ionization manufacturer you're looking at, you do want to make sure that it's not generating significant amounts of ozone above this ETL listing in accordance with UL standard 867. That's for electrostatic air cleaners. So any bipolar ionizer, you want to make sure they're below 0.005 parts per million of ozone. As far as Plasma Air is concerned, our product is below 0.001 parts per million. And this threshold is really what like a thunderstorm creates, same amount of ozone that a thunderstorm creates. So we're well below that standard. And you want to make sure that it's meeting this standard, regardless of who you're looking at. So I kind of went through that quickly. Any questions on bipolar ionization, how it works? before I get into studies and things like that.
No, I'm good.
Where do you install that?
So this could be installed at your fan coil units. It could be installed like UV in your air handling unit, in duct. Really, there's a lot of different delivery mechanisms. I'll skip ahead. Like this is our needlepoint PA660, and you could install this on a fan coil unit on the inlet of the fan. And basically these two arms have the needles on them, and they're going to positively and negatively charge the air that's going through them. If you want to look at a duct mounted application, this is the needlepoint style 7000 series. That's just mounted into the side of the duct. And then your bar series would be mounted in the air handling unit itself or rooftop unit.
Which is more effective?
They're all equally effective. Honestly, if you want to do it all in one place, the air handling unit one would be, or rooftop unit, you could install this in a rooftop as well, would be the way to go. Really, it has to do with your ion concentration. So you want to make sure that you have at least 1,000 ions per cubic centimeter. That concentration is what this study was performed at. So this is the most recent, kind of, for us, most exciting study that was performed. This is by the Spanish Ministry of Defense. And basically, they took a hotel and converted it over to be a hospital to care for COVID patients. And they installed this needlepoint unit inside of one of the fan coils in the hotel. And they used a coronavirus surrogate, so not COVID-19, but a surrogate for it, and determined that after running the unit for 10 minutes, the surrogate was 99% deactivated in the air and 80% on surfaces. So not only, are you seeing it being taken care of, but it's ongoing. Anytime that fan's running, you're pumping ions into the room that are constantly searching out and destroying these airborne pathogens, as well as odors, and making the air cleaner, less dust, things like that. So this is, again, the most recent study. We'll be happy to share this with you as well. But kind of our battle flag in terms of this whole epidemic as it pertains to this disease specifically. So any questions on that? Luke, if there's anything I missed on the study, go ahead and share.
The only thing I think you covered it all on the study. Shane just wanted to be readmitted. I think you covered it all on the study. The other thing I would say is when I look at this as a technology. So Plasma Era as a manufacturer does different type of ionizing technology. The one we promote as a company is called bipolar needlepoint ionization. So if you look into ionization, you kind of have to follow that route down to what that actually is, because there's different ways you do it, and those different ways produce different byproducts and things like that. Also, the other thing I would say is while this was done with MES2, there was a competitor to us that did do an airline test. So it was had to be done in a level 4 lab with actual COVID-19, and it did pass the United States airline registration for an air purification device. So this technology is proven with actual COVID. While it wasn't us, it's literally the same exact technology. So far as there was patent lawsuits 10 years ago when they came out with it. So it has been done with COVID. This is more of the real world application, and did it on a fan coil in a hotel room, and did prove that it does actually have an effect, because the baseline, one thing that I found was a little weird was the baseline really didn't decay very fast of MES2 concentration. So that kind of goes the route of this will be transmitted airborne as well, which is a big fight in the medical field, if you guys know that right now. But no, I think you hit it really well. Any other questions?
No, I know we are reaching to a few minutes, but Rich, we need to get some idea, and if you can able to put some ballpark estimate on for each of these, and what will it require for maintenance and what it will cost. We need to put some budgetary number somewhere. And we can discuss this with our infectious control people as well. And I
Okay.
want to get their input as well. And maybe we might ask you to do the same presentation to other group of people.
Yeah, we're happy to do that.
Other people are interested to listen because they are the one, they're going to make a decision, and decision comes because they do test themselves about all those things. So they are the people who can tell us, yeah, no, we are not interested. Yeah, we are interested, whatever the case. So
Okay.
that will
And
help
we-
you if you're ready to give all the answer, or here is approximately cost, blah, blah, blah. Just take one or two air handling units. We got air handling units from 20,000 CFM, I think, if I'm not mistaken, 210,000 CFM size. So,
Okay. I mean,
Something-
even if you wanted us to come out and measure some air handling units you have in mind to give you a real life example, we'd be happy to do with that. Or if you just want to do, an approximation based on the dimensions of the air handling unit from what you guys have.
You're most welcome to come and visit and probably be prepared that. So we are not guessing anything. We are
Okay.
stating the facts. So everyone can see that, yeah, you came out and you did measure and this is what it is, blah, blah, blah.
Okay, that works for me.
And if they decide to move forward, then we can go from there on.
Okay.
Is there a fair statement, Shane?
What's that?
No, I said, is that a fair statement? I
Yes.
said.
Yes, that is. You kind of cut out a bit. Yes, that's a fair statement. I'd really like to see we choose one of our hospital air handlers and then go from there and get an understanding based on one of our current units.
Yep.
Okay.
And maybe this might be, if we need Shane, we can talk about putting into our Mitchell. Who knows? So we need to get Allison to get educated and see what her thoughts are.
Yeah, this is a good idea.
Yeah. All right.
All right. Great,
Well,
guys. Well, thanks for, that's pretty much all I had. I mean, there were two other, it's all the same technology, but two other slides I had, which cover, there's a ceiling scrubber version of this and there's a portable version of this. So if you had a place that you needed to wheel it into, we have that to offer as well.
Okay.
That about covers it.
Okay. Sounds good.
Great. Thanks, guys.
Thank you. Very well informed.